Hi everybody. I'd like to show you another example in determining if a subset is a subspace of a vector space. For the second example, we're again going to be working in the vector space R4, and we want to look at the subset W, which is the set of all vectors of the form A, B, C, D, where A is equal to 1, B is equal to 0, and C plus D is equal to 1. Now, this part here should be similar to a problem that you have in the homework. Alright, so similar to last time, we first want to decide what we think. Do we think this is going to be a subspace, or do we think it will not be a subspace? This may take some work on an additional sheet of paper for you to decide. If that's the case, make sure that you take that information and rewrite it as a neatly organized solution that you can hand in. Alright, so we need to decide if it's going to be closed under addition and closed under scalar multiplication. Now, there's a couple of things that we could look at here. We saw that an entry being 0 should actually not be a problem at all. That's what we saw on the last example. So this, I don't think, is going to cause us any real issues. But A equal to 1 and C plus D equal to 1, those may cause some issues. So where do we think that we might have a problem? Well, if we take A equal to 1, then certainly if we take two vectors which both have an entry of 1 as their first entry, then when we add them, 1 plus 1 will be 2, and the first entry will no longer be 1. So this will not be closed under vector addition. Okay, so we can see that because if if we take two vectors where both have first entry 1, when we add the two vectors, the addition will have a first entry of 2. So this causes a problem. So we could immediately write that down and be done, because it is not a subspace. But we may also want to take a look at this. If we take the scalar multiple of a vector which has C plus D equal to 1, then let's say we multiplied by 2. Then 2C plus 2D is 2 times C plus D, and since C plus D is 1, that's 2 times 1, which is 2. So when we take the scalar multiple, we will find that C plus D is equal to the scalar multiple, not 1. So let's actually take a look at both cases here. Let's let U be equal to, we know it has a first entry of 1 and a second entry of 0, and then we're going to say U3 and U4. Then we're going to let this be in W, and we're going to let V be equal to 1, 0, again because we know the first entry is 1, second entry is 0, V3, V4, and we're going to let this also be in the subset W. Now, being in the subset W tells us that U3 plus U4 is equal to 1, and V3 plus V4 is equal to 1. That's by this condition here. We should also let C be a real number. Okay, we'll use these for vector addition, and we'll use one of these and that for scalar multiplication. So let's check for closure under addition. U plus V is going to be equal to 1, 0, U3, U4 plus 1, 0, V3 plus, comma, V4. And the addition of these two vectors is going to be 1 plus 1, 0, U3 plus V3, U4 plus V4. And this is certainly equal to 2, 0, U3 plus V3, U4 plus V4. But 2 is not equal to 1, so this is not in W. and W is not closed under addition. We could stop here. It's not closed under addition and simply say, we can simply say that W is not, the subset is not a subspace. Okay, so we could be done here. But let's take a look at the other situation, the scalar multiplication. Okay, so you could be done here, or you could look for closure under scalar multiplication. So let's take C times U, which is C times 1, 0, U3, U4, which is equal to C, 0, CU3, CU4. Now in this case, it clearly does not have the first entry be 1. Alright, the first entry is not 1 unless C is 1. But we could say that, UN, unless C is 1. But, so we could choose C not equal to 1 and show that it's not closed under scalar multiplication. Alright, well, so W is not closed under scalar multiplication. So W is not a subspace. Excellent. Okay, so these are what we're looking for. We could have stopped here, or we could have stopped here. But let's take a look at U3 and U4, because that's similar to what you guys will have in your homework. So we can also notice that U3 plus U4, which we want to be equal to 1. And actually here we're taking the third and fourth entry of the scalar multiple. So CU3 and CU4 is equal to CU3 plus U4. Okay, which is equal to C times 1, since U3 plus U4 is 1, which is equal to C. Again, C is not equal to 1, so the sum of the third and fourth entry of our scalar multiple is not equal to 1, unless C is 1 in this case. So we could choose C not equal to 1. Therefore, W is not closed under scalar multiplication, and we can say that W is not a subspace. Okay, so we could have stopped here once we showed that it is not closed under addition. We could have stopped here when we showed that it was not closed under scalar multiplication, or taking a look at the third and fourth entry, here we also see that it is not closed under scalar multiplication. We could have stopped at any one of these 3 points. We could have not included this, and only written this case. Right? Take the scalar multiple and show third and fourth entry are not 1. Take the scalar multiple and show the first entry is not 1. Or find the addition and show that the first entry is not 1. Any one of these 3 choices would have been appropriate. You do not need to show all 3. If you have any questions, please let me know, and I'll get back to you as soon as I can. Thank you.